For section 3.1, we're going to be taking a look at what are called quadratic functions. There's a couple of ways of writing quadratic functions. The first one we're going to look at is called the standard form of a quadratic function, which goes f of x equals a x minus h all squared plus k. Within the quadratic function, the letters a, h, and k are going to have significance on what the graph looks like. First off, if a is less than 0, then our quadratic function creates a parabola, is what they call it, that points downward. The point up at the very top of this downward pointing parabola is called the vertex. And we see how it tells us that the vertex occurs at the point h, k. So we locate the coordinates of that very easily by looking at the function in this form. On the other hand, if a is not negative but a is positive, greater than 0, then the quadratic function will be a parabola pointing upward. We still have our vertex now, but now it's going to be down at the bottom of the parabola rather than at the top. We have something that's called the axis of symmetry that it lists here. The axis of symmetry, it says, is x equals h, because h is right down the middle of the parabola and cuts it right in half if we look at a vertical line going through x equals h. So we're going to follow a process right now and take a look at some quadratic functions and consider what the graphs of these will look like. The first one we're going to look at is f of x is equal to negative 2 x minus 3 all squared plus 8. The first thing we're going to do to go about drawing a sketch of the graph is to answer the question, does this thing open up or down? We can determine whether or not it opens up or down by looking at the number for a. A in this case is negative 2. So since a is negative, when a is negative, it opens down. So I'll put my little arrows on my letter N to show that we're opening a parabola downward here. The next thing we determine is the vertex. The vertex is the point h, k. K is the number that's at the very end here. That's the 8, the positive 8. To figure out what h is, I'm going to take x minus 3, set it equal to 0. To figure out what h is, I'm going to take that thing in the parentheses, x minus 8, set it to 0. And if I add the 3 over, it would be x equals 3. That tells me that the number for h is 3. So our vertex here would be the point 3, 8. Then the other thing we're going to do here is determine the x intercepts. To find the x intercepts, like we do for pretty much everything, we set y or f of x equal to 0. Here that would look like 0 is equal to negative 2, x minus 3 all squared plus 8. So I have to solve this thing for x at this point. To solve for x, I'll go ahead and subtract the 8 over. We'll be solving negative 2 x minus 3 squared equal to negative 8. Then I have to divide over the negative 2 from both sides. That's going to turn into x minus 3 squared is equal to 4. From there, since it's raised to the second power, I actually need to take now the square root of both sides, keeping in mind it needs to be a plus or minus square root of 4. That's going to bring the second power down to just x minus 3, and the square root of 4 is 2, so that's going to equal to plus or minus 2. We now need to plus 3 over to both sides. And that's going to tell me that x is equal to 3 plus or minus 2. So that could be two different numbers. We could have x equals 3 minus 2 and x equals 3 plus 2. So x could be equal to positive 1, or x could be equal to positive 5. So our x-intercepts here are at the points 1, 0 and 5, 0. Now after finding the x-intercepts, we're going to find the y-intercepts. To find the y-intercept, we set x equal to 0. So plugging in 0 for x would look like negative 2, 0 minus 3 squared plus 8, which would look like negative 2 times negative 3 squared plus 8, which would look like negative 2 times positive 9 plus 8. And that's all equal to negative 10. So our y-intercept would be happening at the point 0, negative 10. Now, once we know all these things, the x-intercept, the y-intercept, the vertex, and whether or not it opens up or down, we're ready to draw a sketch of the graph. We'll locate our x-intercepts at 1 and 5. Our y-intercept is down at negative 10. Down there. Our vertex was at 3, 8. And we know the whole thing is pointing down. So we need to draw a parabola that comes up through here, goes up to the vertex, turns around, and goes back down. The only other thing we might make note of is that thing called the Axis of Symmetry. Axis of Symmetry here would be going through x equals 3, right down the middle. For here, we're going to look at f of x is equal to x plus 3 squared plus 1. At first here, I'm just going to go ahead and figure out what the a, the k, and the h are equal to, since that's what we needed to use last time. A is out in front, so a here is equal to 1. Like last time, to figure out what h is, I'm going to take the x plus 3 in the parentheses, set it to 0. Solve it, we have x equals negative 3. So that tells me that the value for h is also negative 3. And then k is equal to the positive 1 here at the very end. So that's going to help me draw the graph, because the first part is to figure out if it opens up or down. So since a is equal to 1, it's positive. My graph is going to open up. Then second is the vertex. The vertex is the point, again, h, k. So our h, k here would look like negative 3, 1. Then we need to figure out what the x-intercepts are. For the x-intercepts, I'll set the whole thing equal to 0 and solve for x. I'll have to subtract the 1 over. At this step, however, we take the square root to try to reduce down the power of 2. But on the other side, we're going to be seeing a square root of negative 1. As a result, we can say that there are no real solutions to our equation that we're trying to solve, which actually tells us that there are no x-intercepts here. We can still try to find the y-intercept, however. And we do that again by plugging in a 0 for x. So it would look like 0 plus 3 squared plus 1. So that would be 9 plus 1, or 10. So our y-intercept would be the point 0, 10. Now we have all the information we can use now to get to the graph of our function. We only have two coordinates to speak of. One of them is a vertex at -3, 1, and the y-intercept at 10. And since we make note that the parabola was opening upward, it's going to open upward, come down to the vertex, turn around, and go back up, passing through the y-intercept of 10. We have a different way that a quadratic function can be written, which is called the general form of a quadratic function. And that would be f of x is equal to ax squared plus bx plus c. This form is very different from the other form. We actually have a formula for finding the vertex. That goes -b over 2a, comma, f of -b over 2a. The axis of symmetry is also now calculated by x equals -b over 2a. So I'm going to go through some examples of a general form of the quadratic function and how it's going to look to figure out the information we need to draw a sketch of the graph. Here we're going to look at -4x squared minus 8x plus 3. And how we figure out this one, first off, I'd like to identify what a, b, and c are. In this case, a is 4, b is -8, and c is 3. So first things first, we can actually tell is if this thing is opening up or down. Same information would apply that did for the other function. We look at the number for a. A is 4, which is positive, and so indeed it will open up. So no change in how we can determine that from the other form. This one, though, will be different. Finding the vertex. The vertex now will be figuring out by using -b over 2a. Here that would look like -8 over 2 times 4, which would look like -8 over 8. Negative would turn this into a positive and a positive 1. That's going to tell us the x-coordinate of our vertex. We have to plug that in to get to the other part of the vertex for the y-coordinate. We have to plug in and calculate f of 1. That would look like 4 times 1 squared times 8 times 1 plus 3, which would look like 4 minus 8 plus 3. And that would be equal to -1. That gives us the y-coordinate of our vertex. So our vertex would be the point 1, -1. Following the same steps as before, we figure out if it opens up or down, the vertex, and then we find the x-intercepts. We're finding the x-intercepts again by setting the whole thing equal to 0 and solving for x. So 0 equals 4x squared minus 8x plus 3. So there are two ways we can solve this type of equation. One of them is by factoring, and that's generally our first choice if it's possible. And another way is by using the quadratic formula. If you'd like to try to factor it, you might want to pause the video here and see if this one looks like something that we can factor. I was able to factor it into 2x minus 1 times 2x minus 3. And that's good because once I'm able to factor, I can set each of those equal to 0. So we have 2x minus 1 equal to 0, 2x minus 3 equal to 0. And then we just have to solve for x. I'll plus 1 over 2x equals 1 divide out the 2. So we'll get one solution of x equals 1/2. On the other one, we'll add the 3 over. We'll have 2x is equal to 3. Divide the 2. X is equal to 3 over 2. So we have two x-intercepts here, one that goes 1/2, comma 0, and another of 3 over 2, comma 0. We might also think of those as 0.5, comma 0, or 1.5, comma 0, depending on if we want to look at it as decimals or as fractions. Now for the y-intercept, we'll plug in 0 for x. So f of 0 is equal to 4 times 0 squared minus 8 times 0 plus 3. Did that calculation and I came out with 3. So our y-intercept would be the point 0, comma 3. Now I have all the information I need to draw a sketch of the graph. Okay, using the points that we received, we had a y-intercept at 3. We had an x-intercept at both 0.5 and 1/2 and 1.5. We also had the vertex over at the point of 1, comma negative 1. So now we know our parabola opened up, so it's got to open up, come down through here, down to the vertex, turn around, go back up through the x-intercept. On this function, we'll be looking at f of x is equal to x squared minus 2x plus 3. Following the same steps I did before, we have it a is equal to 1, b is equal to negative 2, and c is equal to 3. The first thing we'll do is we'll check the number for a. It's positive 1. It's positive, so that means its thing will open up. And then we check to see where the vertex is. And for the vertex, again, we use negative b over 2a. And so I plug that in, would look like negative 2 over 2 times 1, which would be negative 2 over positive 2. Negative, we'll turn this into a positive 1. And that's the x part of our vertex coordinate. We have to plug that into the function to get the rest of the vertex. So it would look like 1 squared minus 2 times 1 plus 3. And that would equal to positive 2. So our vertex would be the coordinate 1, comma 2. And then next we'll find the x-intercepts. And then we set the whole thing equal to 0. 0 equals x squared minus 2x plus 3. Now you may want to pause here for a minute and think, will this thing factor? Since that's usually our first choice for solving it. In this case, it will not factor. So our only option then is to use the quadratic formula. So to do the quadratic formula, we'll set up here with x is equal to negative b, negative 2, plus or minus the square root of b squared minus 4ac all over 2a. So when I run through the quadratic formula here, it's going to start off with positive 2 plus or minus the square root of 4 minus 12 all over 2. But pretty quickly here we're running into something. This would be now 2 plus or minus, and when I minus 4 minus 12, it turns into negative 8. So it's square root of negative 8. So what this tells us is, in this case, there's another case where we have no real solution. Square root of a negative number is not a real number, in other words. So this is another case with no X intercept. So we'll go ahead and wrap this up, finding at least one intercept with the Y intercept. We'll plug in 0 for X. So it would look like 0 squared minus 2 times 0 plus 3 would just be plus 3. So 0, 3 is our y-intercept. So let's go ahead and sketch the graph as best we can. We had our y-intercept here at 3. We have our vertex at the coordinate of 1, 2. So we'll draw our parabola coming down through the y-coordinate, down to the vertex, turning around, and going up from there.